Hello, in this video, I will present how we use these 20 sticks from Fagor and how we implemented these 20 sticks into Java class. First of all, we went through this document and taking into account 5 categories like security policy, user rights, audit policy, registered, and cross mitigation. We were guided by these PowerShell scripts and description of each stick findings. And based on that information, we created the hierarchy of the classes. Firstly, I will show you how we mapped Fagor categories to our Java class. We have security policy and its abstract class in Java security policy requirement. User rights is equal to user rights requirements. Audit policy requirement. Register edit requirement. And finally, process mitigation requirement. All these 5 classes are grouped by parent class. It calls requirements. And it has category check enforceable requirements. Now I will show you how we implemented this requirement and check enforcement requirement and why we need it. So we have in our repository class requirements. It has the same structure like a stick finding. If we take a look detailed, we see here that we have version, rule ID, EA control, severity, and description, and etc. date. If we take a look at the example of each stick, you can see here the same structure: finding, version, rule, EA control, and severity. Also, if we go to check enforceable requirement, we see here that it just extends from 2 classes: checkable and enforceable. Basically, we need this category to combine verification of the sticks through checkable and enforceable classes. If we go to checkable, we can see here that it verifies the environment to satisfy the requirement. And the result of this verification is pass, fail, or incomplete. Also, if we go to enforceable, we see here that if we modify the hosting environment, we verify whether it satisfies or not. And it verifies the outcome of the process of verification. Also, it has success, failure, or incomplete result. I suggest to take a look detailed for one branch and explain how we implemented the one stick group of rules and through abstract classes, and how we created these patterns and how can we verify the stick findings. So let's take a look in detail to security policy requirement. It has 2 abstract classes: account lockout policy and password policy. And based on the stick document, this sticker security policy includes 4 stick findings. This one: 63405, 63409, 63423, 63427. And these classes have the same basically common characteristic for check text and different results. And if we go to the document, we can see here that there are some ways to verify, and there are some, let's say, PowerShell scripts to meet these steps of execution. So in Java code, let's go to security policy requirement. And in Java code, we applied function to verify these different rules. And basically, we here described this, which he described the way of verification through check text template and the result and the path of verification, so fixed text template. And the most interesting part is how we verify different rules because they have different structure, and we applied hash map function. So this hash map, it verifies different rules. Let's consider here on the example. For example, we have here this rule, yeah, like the same steps of verification: verify the effective settings in local group policy editor, run a graded MSC, and the path. And here the condition to verify this rule. And another rule has another condition. And we had to combine these all rules to some one function. And that's why we used hash map. For example, some findings, C findings, has some length of characters condition. Some condition has a number of attempts, and also we have condition about password. Is it enabled or disabled? And also we have account lockout duration, 15 minutes. All these conditions were implemented in hash map. Here we have these conditions like a template. And here we have these numbers: 3 attempts, 15, and 14, like a duration. And when we execute verification through this security policy requirement as a pattern, we also apply the classes to verify the category, value type, common key, and methods to call this verification in final classes. And I will show you how we do it. So we create this pattern, and this pattern has two subcategories. It's an account lockout policy and password policy. So we combined these two findings into some category. Let's take a look at these two findings: 63405 and 63409. So here we have 63405 and 409. The first one, 405, it describes the duration, lockout duration, 15 minutes. And here we have the number of attempts, 3 attempts. And let's go to their category. It calls account lockout policy. And X, it extends from the pattern, security policy requirement, and it returns get common key 1, and it returns category account lockout policy. Why we need it? So this category allows us to combine common characteristics and return the result of verification. When we go to these final Java classes, 63405, 63409. This Java class extends from this category, and it totally is a mirror. It's a mirror of STIG finding. So here we have the check text code, date, finding ID, fixed text code, EA controls, rule ID, and etc. So again, let's take a look at this class, and here we have the same like structure in Java class. The most interesting part in the bottom. So we have to return the text what we have in details. So using the get checks text additional, we describe this text, and through get inclusion settings, we return the value of success verification. Again, here we describe through check text additional and get fixed text additional the text that we have here, check text and fixed text. And we address to get inclusion setting that that's included in pattern, and through it we return the value. In our case, it's 15. It's account lookout duration to 15 minutes or greater. So, and also we have get option. It returns account lookout duration and value lookout duration. So these three methods, they allows us to return the result of verification. And if we go to the another stick and about number of attempts, we have the same case. Also, we have the get check text additional and get fix that describes the information from check text and fix text of the stick findings. And we have here the result of verification, the return number 3 at get inclusion static, and get option, it's account lookout threshold, and value type, so lookout bad count. All this verification are taken by the parent pattern. It's called security policy requirement. So here we described, and we can change to any other values, and it allows us, for example, changing one pattern to change another subclasses, and it can save our time, and it can ensure the better maintainability of the source code. Getting back to another classes, we apply the same rule. For user rights, audit policy, register, edit, and process mitigation, we have the same principles. These classes are patterns for these final stick findings. And we describe all the rules and the way of running PowerShell scripts at these Java classes. So you can find all the information in our very DevOps repo, and here you can find the documentation, description, and you can take a look at the source code. Thank you.